Welcome to Brain Vision.
Okay, this is question 5108. We have a physics major who is riding a motorcycle inside of a hollow, transparent plastic sphere. And we know that she's going to be traveling in a vertical circle with radius 13 meters. And she has mass, I'm labeling her mass as big M, that's 70 kilograms, and the motorcycle has mass 40 kilograms. Now, in part A, we're asked what minimum speed does she have to have at the top of the circle in order for the motorcycle tires to remain in contact with the sphere. So to solve this, we're going to need to set up this, we're going to need to use the fact that the sum of the forces equals the mass times the acceleration. And here, let's consider the physicist and the motorcycle as being one unit. So let's say that the total mass here is just going to be m plus m. This is the total mass of the system. Since they're traveling together, they're going to be traveling at some constant acceleration. So let's think about the forces on this motorcycle. So there's going to be some normal force in between the sphere and the motorcycle tires. And there's going to be gravity pulling the motorcycle down. So that's, again, going to be our m plus m times g. That's going to be negative because this is going to be a downward force. And then we're going to have an acceleration. Now, when the motorcycle is at the top, the acceleration is going to be also down because it's going to be pointing in towards the circle because we have centripetal acceleration here. So again, we have m plus m. This is the total mass. And now the centripetal acceleration is going to be, again, negative. So I'm going to put a minus sign here. Centripetal acceleration is v squared over r, where r is the radius of the circle. So we now have this equation. This should be describing the total forces up at the top of the sphere. And we're asked about the minimum speed that she would have in order for the motorcycles to remain in contact. So if the tires are no longer in contact, then this normal force is going to be equal to 0. So to find this minimum speed, let's set the normal force equal to 0. So let's do this here. I'll call the minimum speed v0 just to make this easier. So we have our normal force equals 0, which leaves us with this term here and then this term here. Now notice there is a minus m plus m term in both of these, so I'm just going to cancel that out, cancel out the negative sign as well. And that leaves us with this. So our v0 squared is equal to g times r. And we know g is 9.8 and r is 13. So when we multiply that and take the square root, we're going to get that v0 should be equal to 11.3 meters per second. So this v0 is the minimum speed that we would need to have, that she needs to have in order to not fall off the motorcycle or fall down on this sphere. Now part B asks, at the bottom of the sphere, of the circle, her speed is twice the value calculated in part A. So her v is now 2 times this v0. And we want to know what is the magnitude of the normal force, so this n, exerted on the motorcycle by the sphere at this point. Now, what we're going to want to do is we have our equation here. And again, this should be, this equation is going to hold true for everywhere on the circle, except at this point on the bottom, her acceleration is going to be pointing up. So I'm going to make this positive. And now we have 2 times v0 here as our v. So when I plug that in, 2 times v0, this whole term is going to be squared. So if I want to simplify this, I can use some of our information that we've found up here already. So I can set, we know before that our m plus m times v0 squared over r is equal to m plus m times g. So this is, remember what we got from here with our normal force equal to 0. This is with our, this is what we found here. I'm just leaving in the extra factors of m here. Because when we now substitute, when we get this extra factor of 2 squared, this is going to give us, on this side, just going to copy this, a factor of 4, because now we have 4 times this whole quantity. And remember, we just found right here that this quantity, that's equal to this right here, is equal to m plus m times g. So this is from this initial equation up here. So I'm just using this to simplify our math here, because what we get when we plug this in is that this is all equal to g. So basically using, since v0 squared equals g times r, which we found before, I can just plug that in to substitute this for g. So we now have n, then we have this minus m times g, and then we have 4m times g. So when we solve this, we're going to get a factor of 5 times m plus m times g. And now we can just plug everything in. We know that m plus m will be 70 plus 40, which will be 110. And when we plug all of this in, we should get that our normal force is equal to 5,390 newtons.